All right, we are live. Hey everyone, thank you so much for joining us today, and we'll give it a couple minutes for our viewers to join in, just a minute or so, and then we'll get started with the session. Let us know where you're joining in from today, and if you're interested in lake houses or you are trying out different table formats, Apache Hudi. If this is something of your interest and you're already implementing at your organization, let us know how you're doing that on our LinkedIn page. Right. All right, I can see some people join in, so that's great. Cool. I think we are pretty much ready to get started, and we can have people joining in the meantime. So thanks everyone for joining us for the sixth episode of Lakehouse Chronicle with Apache Hudi. With this new series that we started last year, we always try to bring exciting talks and content for the Hudi community. Typically, we have discussions on critical topics. We go over the architecture internals, things that have been newly released. Do some show and tell on how to get started with Hudi. Some of the interesting projects that our community member do, we highlight those things as well. And of course, whenever we get a chance, we interview our PMC members and bring out interesting insight within the Hudi community. So overall, the idea is to make things easier for developers and users to get started and use Hudi in their Lakehouse workload. So irrespective of if you are an already experienced Hudi user or contributor, or someone who is completely new to the entire space of Lakehouse and specifically Apache Hudi, you should be able to find a lot of beneficial content over here. Another note is that we will also have a recorded version for these sessions, so that way you are free to explore them afterwards, or in case you're not able to join the live sessions like this one. We already have 5 episodes out in our YouTube channel, so youtube.com/@ Apache Hudi. Feel free to subscribe to the channel. This is a playlist that I wanted to pull it up. The episodes are already there. They're really good materials to get started with Hudi and then learn the journey overall, bring data from operational databases, using different kind of tools within the Hudi ecosystem and such. So my name is Dipankar, and I'm your host for today. I work as a staff data engineering advocate at onehouse.ai, where I contribute to open source projects like Apache Hudi. And today's session is going to be all about change data capture in lakehouses and how Apache Hudi kind of helps here. If you are data engineers who have worked on bringing on operational data from operational databases or transactional system to Lakehouse for your analytical use cases, you understand the importance of change data capture, right? So this will be led by our speaker, Sagar. So I'm going to introduce him next and bring him up to the stage. Hey Sagar, welcome to Lakehouse Chronicles. Thank you so much for joining us today and taking the time to talk all about CDC. I'll let you, introduce yourself to our viewers and then take it forward from there.
Thanks, Dipankar. Nice to be here. I'm Sagar. I'm part of the solutions team at One House, and I live in the Seattle area, and I've been with One House for about a year and a half now. And since joining One House, I've been somewhat semi-active in the Hudi community and other open source communities as well. So this is a topic that we deal with at production scale at One House, and it's good to talk about this with the community and share some of my thoughts around it, and also what are the popular ways of people doing CDC in general. Awesome. Happy to be here. Now, if we see what led to CDC, we'll have to take a step back and see what traditional data pipelines are about. In a traditional analytical data pipeline, if you see, engineers would move data from your OLTP systems like Postgres to OLAP systems like Teradata, or imagine any other data warehouse at a regular interval, right? It's basically, if you boil it down to its core, it's an extract job combined with a load job. Right? That's it. That's pretty much what people have been doing up until a couple decades ago. How they do it would add more complexity to the pipeline. Now, there is two ways to think about this. Like the first way is the most straightforward way. It is not very uncommon, by the way, is to copy the whole OLTP table and then load it into the OLAP data warehouse or a database system, right? Now they would do it, let's say, on a monthly basis. They would copy Jan month's table and put it into the OLAP. Now, come February or come March, they would copy the February month's table. They would put it into OLAP. Now, at the end of the year, they would end up with 12 different tables. And if they want to do some historical queries that would span across the entire year, they would do a query time join and gather whatever insight they want to gather, right? And this is not very uncommon. While they are copying or after they copy, they would delete or archive their OLTPs. That way they could like save that precious database storage, right? The second way is where there is a little bit of an intelligence, right? Now engineers would add checkpoints to track how much they've copied, if they're copying only the deltas, right? And what is the starting point and ending point of that copy, right? That way, if that is stored, they could go back again and pick up where they left off and only copy the deltas, not necessarily copy the entire table, right? So checkpoints is the main thing to tackle. Scheduler is another one, right? Because this has to be automatic, and typically people use Airflow or some kind of other scheduler to do this on schedule. I've seen a lot of people just using cron job to do this, and that works well. There's nothing wrong with it. Just that you have to bake in a lot of logic to do task retries and all of that. But it can be done. It has been done. And another one that you have to obviously take care is that a lot of these things are manual, right? You have to poll for updates, you have to poll for inserts, you have to poll for deletes, and codifying that whole thing might add to your workflow. That way, it becomes a nightmare when it comes to rolling it out to production or even like scaling up as it is required. Right? Let's see, why CDC is important or how CDC is going to solve any of these problems. Let's also see what kind of ways are there to do CDC in the first place. And at the end of this presentation, let's also look at a short demo I've spun up locally and talk about or show you guys how it's been done in a small scale. That way it can be expanded at a production level. Moving on to this slide, the first way, like we discussed in the last slide, is more straightforward, right? You're just picking up data and putting it in somewhere, right? But the problem with that is when you pick up data and put it somewhere in its current form, you lose the data lineage, right? And it's too damn expensive because the resource usage to move an entire month's data from one place to another is obviously costly, right? Especially when you don't want to move the entire thing. You just are looking for the deltas, right? But the second way, it gives you flexibility, but it comes with a lot of development overhead, like we discussed. And it would bottleneck when your OLTP scales, like, suddenly when you're processing 10x amount of the data that you're originally processing. Now think about a day where you have your Christmas holidays or New Year's Eve and you're a shopping company, and during those 2 days you're going to copy a lot of data, right? And you have to take all of that into account. It becomes very inefficient because these are query based transactions, and every time you're polling for the changes, you're going to hit your production system or production database, which is not very good, especially when you have a strict compute or strict storage on your production database, right? And to wrap it up, none of these architecture or both these architecture, they're not automatic, right? The first one is obviously human driven. The second one, even though there is a little bit of scheduling, it is not event driven, right? As in, like, it's not being moved as and when the transaction is happening. So that is another pain point. Now, if you take a step back, or if we take a step back and see what actually CDC is, it's that when your OLTP undergoes some kind of change, let's call it, insert or update or delete, basically a change, this tool will be able to pull and process these changes as in when it's happening, right? Now, you can then send it to downstream where a data warehouse or a data lake house can consume, right? What's important is that you would still have to bootstrap the initial database. Like, for example, you're dealing with a 10 terabyte database, right? So you would initially have to bootstrap the database and put it into data lakehouse. That is a one-time operation, though. But every time there is some change, let's say, for example, you are expecting 10 gigabytes worth of change on a daily basis, then as and when that change is happening, these changes will be propagated downstream. Right? This is very much event driven, right? That makes a lot of difference, right? Because there's no cron job that runs on a regular interval. Even though there can be some kind of an interval, it's typically within like seconds or minutes, not really like, hours or days. Now, in this CDC architecture, if you go one level deeper, right, how do people do it? Like, if you strip down all the fluff around CDC, this is what will remain, right? In this architecture, you have a source database, like imagine a Postgres instance, where you have inserts and some kind of changes that's happening, right? And then your CDC tool comes into the picture. This CDC tool, will have some kind of a replication layer. An example is Debezium. We'll look at what Debezium is and how Debezium is going to help later down this presentation. But imagine a tool like Debezium, which is designed to capture all the changes from your databases, and that is paired with some kind of a messaging platform like Kafka or Kinesis or something, right? Which has the ability to hold on to those messages until certain period of time. There is replication, factor and all of that within Kafka, which makes it easier for you to like hold on to that message, in a good fashion. And you have other tools like Spark or Hudi's Delta Streamer or other tools which can poll Kafka at a regular interval and also push those changes to wherever you want to push it to, like Redshift or something. This is a very common architecture in an AWS ecosystem. I'm pretty sure there are like very common architectures in Azure and GCP and all of that places as well, right? But this is the bare bones of it. Like source database, you have changes coming in. You have some kind of a CDC tool. CDC tool is made up of Debezium and Kafka typically. And you have some kind of an ETL tool, Spark or Flink or something like that. And Spark is integrated on the left side with Kafka Debezium, on the right side with your data warehouse. That's typically how it's done. Now, in the next few slides, we'll look at some of the common CDC patterns, how people do CDC, how people look at CDC, and also discuss the pros and cons of each one of those types. Now, the first one out of 3 or 4 common CDC patterns is this timestamp and query-based CDC pattern, right? Now, I'm not sure how well it is visible. That's on me. But if you look at the first table here, that is a query result of, say, an insert query, right? Some kind of user table where user's name is being inserted, and you have a created timestamp and you have a last updated timestamp, right? It's pretty much an insert command which gives you random rows, right? Now, having these timestamps, those are key in this timestamp based or query based CDC pattern, right? And if you look at the second result there, it has undergone some kind of an update, right? Now, what that update is, it can be anything. But the key thing to note there is you have the last updated changed a little bit. Now, the created timestamp is in 2023, updated timestamp is in 2024, right? So after a year, there has been some update, but that's the situation, right? Now your application, let's discuss what that application is. But the application is capable enough to pull only the delta that is changed, right? So it would ignore the insert, but it would only pull the update, and then it would put it into Redshift because the insert is already put into a data warehouse, right? So this application would poll for this change and pull the update, and it would again transfer to your data warehouse, right? And what goes on in that application is what makes that CDC tool. Now, typically, it's just a SQL query. It can be a complex SQL query, but if you strip down all the fluff, it's a SQL query with a where clause. Where clause would have, greater than some timestamp. And when you run that where clause query, you would get only the deltas, right? Now, in this case, probably the where clause would be where last updated timestamp greater than 2024-07-07. Right? That way you'd get this update, and that update can be put into a data warehouse. Right? As you can see, this method is very flexible, right? Because you are the owner of that SQL query. You determine how to frame, your CDC pipeline should look like. Right? And it typically works with all kinds of database because all databases support SQL queries, right? But but on the flip side, this is very manual, right? Because you are the one who's developing that SQL query, and you have the ownership over that SQL query. You have to maintain that SQL query and all of that, which can be error prone, right? Like anything that a user can do, they can make mistakes. And it is also resource intensive because you're directly hitting your source database, your production database, when you're querying for that delta, right? Now, in this case, it's only one record, but going back to our previous example, when you are dealing with some Christmas holiday as a shopping company, you might have to grab a lot of deltas, right? And that would bottleneck your production source system, which is not what we want. You can add some replicas, all of that, but it would just add to the complexity, right? And also, one key thing to note here is if I go back to what I said before, you need these timestamp fields to make anything possible, right? And you have to retroactively go to your database design and make these schema changes, which is not very fun to do, right? Like imagine a dimension table, which has nothing to do with transactions. It's pretty much tracking what are the places the orders are coming from, right? A city ID and a city name and a state name. Those are not required to have, timestamp fields at all. But in this case, you have to have it, right? Now, all of that is just a cause for concern, right? Now, moving on to the next one. Next one is, it's not that horrible compared to the previous one. Now, this way of doing CDC is, it's called trigger-based CDC. This is another method for building at the application level, and it defines or it uses database triggers, and it helps you create your own change log in shadow tables. Shadow tables are nothing but your change tables, right? Now, triggers will typically fire after each type of query is done. Like you perform an insert, you get a trigger. You perform an update, you have a trigger. You perform a delete, you have a trigger, right? It is pretty much the one that indicates some kind of a change, and that will be used to create a change log, right? And these triggers are required for each table in the source database, right? Like, at its core, you're looking at three triggers: insert, one that triggers after insert, after update, and after delete. Now you have to do that for one table in your database, which you want to do CDC. Let's say you are dealing with hundreds of tables, then you have to have hundreds of triggers multiplied by 3 for each table, right? These triggers are expensive in nature, right? And it'll also have an overhead associated with it because these triggers are supposed to be done by the source database itself, right? and those are having operational tables, and we don't want to do that, right? It'll also have a significant impact whenever these triggers are being made, especially at a low latency interval. Like imagine having inserts every second. Now there should be triggers every second for that case, right? And if you want to do batch up all of these or create a buffer sort of thing, then that's going to add to your development overhead. Those are main talking points as to why trigger-based CDC is not the most efficient way to do things, right? But on the flip side, it has some advantages because almost all databases support triggers, right? And it enables somewhat a semi-real-time data capture, right? Counting in or factoring in the time that it takes to schedule the trigger or actually do that trigger and all of that, right? It's pretty much event driven at this point, like compared to the last time, which is pretty much driven by a cron job. Now we are into the event driven world, right? Because these triggers are fired as and when the event is happening, which is good for us, right? And this gives a nice segue to what we are going to discuss next, which is what I would call a gold standard when it comes to doing CDC, right? This is log-based CDC, right? And for those who are aware, every database or almost all databases that I know of maintains a transaction log, right? Like Postgres has its own transaction log called write-ahead log or val, and MySQL has its own transaction log called binary log or bin log. Like this is a transaction log which captures all the transactions as and when it's happening in the database, right? Think of it as a small log file, right? It can grow as the data or as in when there are a lot of transactions, but it's simply a file at the end of the day, right? Now, what happens here is you have a insert and then you have an update. Both inserts and updates are captured in this transaction log, and your CDC application, let's discuss what the application is going to poll that transaction log at a regular interval, typically very, very low latency interval, right? Like we are talking about milliseconds or something like that here, right? This application will capture those transaction logs at a regular interval, and it will push to a somewhat of a messaging layer, right? And that messaging layer would have this transaction in a defined schema, and it'll hold on to whatever the retention period is, right? And now another ETL tool comes into the picture. It'll pull that messaging layer, and it'll be able to, or it'll give you the option to modify the schema, do any transformations you want, and also make it into a tabular format by flattening that schema, and then it'll give you the option to put it into your downstream database or a data warehouse, right? There are no performance issues here because you are simply reading a transaction log. It's less intrusive than a trigger-based CDC. It is much more efficient than query-based CDC. It doesn't impact your production source database at all because you're not scanning any of that, right? You're simply referring to that log file, right? But those are the advantages, right? It can give you the option to do asset transactions because you can fail the entire transaction if it doesn't go reach your downstream system, right? So there are all of those advantages. You can bake in schema evolution. You can connect to your schema registry while you're doing log-based CDC, and it'll give you a way to evolve your payload structures, right, without impacting your existing pipeline. Now, on the flip side, not all the databases like MySQL and Postgres have a standard logging structure, right? Postgres, like I said, it has its own val, which looks a little different than the bin log that is given by MySQL, which is different than how Oracle does it or how SQL Server does it, right? So if you're a CDC tool, or if you're doing your own CDC kind of implementation, you have to take all of that into account, right? you have to parse these internal log formats, and it can get a little complex, as in when you're dealing with different kind of payloads and whatnot. And if something changes on the database side, let's say, for example, for some reason tomorrow Postgres wakes up and it wants to change its own transaction log, right? Now you have to take all of that into account. You have to be on top of it, and you have to update your replication logic as well. Now, this is ideal when you don't want to disturb the main database, which is almost always the case, right? Nobody wants to disturb their source database, right? And want to maintain some kind of a reliable mechanism in getting those upstream changes propagated to downstream, right? And you want to add schema resolution and whatnot. Now, this is what we are going to discuss in the rest of this presentation, and this is what the demo is all about as well, right? Now, some of these things I've already covered in the previous slide, but just to get everyone up to speed, this is how a bare bone CDC streaming pipeline would look like, right? You see in this architecture, which is very similar to what we saw in the first slide, except you have that one component, which is the data processing layer added to it, right? This has a table format, in this case Apache Hudi. It has a data catalog because Hudi needs some kind of a data catalog to maintain its metadata and let it evolve over time, right? And it also has a schema registry, which helps you, track back and deal with any schema changes from upstream if required, right? Now, on a flow level, when your OLTP goes through some kind of a change, it tracks it in a transaction log. Let's say in this case, Postgres, your val is updated. Those changes are being pulled by Debezium at a very short interval, right? And Debezium has its own payload structure. That payload is sent to Kafka, right? And Kafka retains it for a set period of time, right? So if you go to your Kafka consumer and actually say list topic and also poll, for that specific topic, if you do Kafka console consumer or something, then you'd be able to see that essential message, right, in its own Debezium payload kind of format, right? And this is where the ETL tool comes in a picture, right? Once the data lands in the Kafka, this tool is pretty much like a Hudi streamer job, which is what we use in production. And you also have Spark streaming. You can use Flink to do CDC, and you have all these tools, right? So basically, let's take, for example, Spark streaming job, right? You have a Spark job that listens to this Kafka topic, and it's a streaming job, so it writes to a specific stream, right? Typically, this is some kind of an object storage, right? Like S3, MinIO, or GCS or some other place. So that place is connected with a data catalog, and it is connected with schema registry, which both of them are typically connected with some kind of a data warehouse, let's say a Redshift Spectrum or BigQuery, or even Spark SQL if people want to read these tables in Spark, right? So that is an overall architecture, right? Now the only change is you've added Debezium Kafka into the mix, you've added Hudi data catalog and schema registry into the mix, but essentially you're moving the data from left side, which is your source database, to your right side, which is the target database or data warehouse, right? Now these tools, work in conjunction really well, and it makes it easier to, push your changes as and when it's happening without any manual overhead. There is no scheduling involved here because this is a micro batching kind of solution. It's a streaming job, right? Now, with that said, I have a short demo prepared that I can share. Just give me a second while I pull that up. Dipankar, quick question. Is
Yeah.
my VS Code available? Not right now, right? I'll have to flip my screen, I think.
Yeah. So are you sharing a screen with VS Code or?
Just a second. I'll
Sure.
just
Yeah.
start it.
Yeah.
How about now?
Yes, I can add to stage now. Perfect.
Awesome. Okay, cool. So this CDC demo is a local demo. I'll make sure this is being uploaded somewhere so that people, if they want to take a look, they can. This is built on Docker, which pretty much installs all of these systems like Debezium, Kafka, Postgres, Spark, and Hudi. Essentially, the stuff that we discussed earlier, minus the data catalog and schema registry. Right? Those are a little bit of out of scope for this presentation, but we can pretty much add it like without much of an effort. Right? Just that they have to be locally available. Now, you could bring up all of these containers by just doing a Docker compose. And once that's done, this is how the pipeline would look like, right? You would have your database that is undergoing some kind of a change, right? So changes are being pushed to a database. That's what we are going to do in this presentation. That change will be captured by Debezium automatically because we have set up Debezium to capture it, right? And those changes will be captured by Kafka because we have connected Kafka to Debezium already, and that is baked into the script. Right? And those changes can be captured by Spark with a simple ETL script. And as and when Spark is reading that as a stream, you can also output that into a Hudi table, with a simple API like write stream API, right, within Spark streaming. So this pretty much takes like 10 minutes to go through the demo, but that's essentially what's happening. Now I've set all of this up in advance, so we are not going to set everything up from scratch. I'll show you how a change can impact this pipeline, right? That way it gives you a good opportunity to understand. Now, these are some housekeeping parts, like you have to connect your Debezium or the table to Debezium, right? That's being done with the curl command, and the curl command refers to this JSON. If you look at this, it is a Postgres connector. You give the database host name, you give the database server's name, you give the table name, you give what is the username and what is the password, right? Even if someone is building a CDC tool for production, they would typically have all of these as an input key, right? Like first name, username, password, which table you want to query, and all of that, right? So that's pretty standard. Now, once you have that, you can register the Postgres through Debezium. And once you do that, in a couple of minutes, the connector will be up. You can go check the connector status as well. This would end up showing the connector is in running state, right? Then you bring up Postgres, right? You create a table and you apply all the CDC related properties, right? This table is very minimal. It has a name, email, created at, updated at, and an ID, which is the primary key for us, right? Now, when you insert a sample row, this creates a payload inside Debezium because Debezium is consuming from Postgres's write-ahead log, right? Now, if I go to my Kafka and run this Kafka console consumer, which is a shell script inside Kafka, I can see how this sample message looks like. Now, this was how the sample message was, right? This is John Doe's like email, and when it was created, when it was updated, right? If you look at this payload is like very different to what we inserted, right? But this payload has critical metadata information that can be used when we are processing the message, right, in an ETL job. That's when it gets important. Like this has some metadata information, which schema it's coming from, which table it's coming from, and you have the operation type here. In this case, because it's an insert, you see C, and if it's an update, you see U, and I think for delete you get to see D or something like that. And that's pretty much it. This is how a payload looks like. Now you would start a Spark streaming job. I grabbed this from Hudi Docs. Use Spark 3.5 or whatnot, and you would frame your Spark streaming job like this. Spark read stream, format, we are reading from Kafka, and you're pointing to the Kafka Bootstrap server, and you're subscribing to this specific topic, remember we are doing it on Postgres. The schema is public. We are using users table as our base table, right? And you want to start the offset from your earliest. And there is another mode called latest, which will just poll from, when this ETL job is starting, it would just pick the latest offset and go from there. But we don't want to do that because our demo is like pretty minimal. And I've seen people doing latest offsets because they don't really care about historical data inside Kafka. So in that case, latest can work, right? Now you would define your schema. The schema has to kind of demystify how that Debezium JSON payload looks like. That's where it gets a little like finicky, but nothing too complex here. Pretty much, you have to, understand what schema Debezium is sending to, and then you can use to create your own schema inside Spark. Now, some parsing going on here. After that, you add your regular boilerplate Hudi options. In this case, not very complex. And then you'd go to write your stream in Hudi format, point to your Hudi options, set up some checkpoints and output mode, and then start writing it to this specific file location, right? Now, let's see how this file location looks like now. And then let's insert one more record and let's see how that table changes. Now I'll go to my Spark container. Spark container I've just like tried to list what files are there inside this Hudi underscore users table, which is where we are writing to from our Spark job. Now this is a Hudi table. If you see, it has Hudi metadata and everything. There are like 4 Parquet files, right? Let's try to insert one more record into our Postgres users table, and let's see how this Spark job would like capture those changes that's happening in Postgres and put it into our Hudi table, right? Let's go to our Postgres instance. This is our Postgres instance. Here, I'm just adding a new character. Let's do Charlie Pew. Let's do Charlie P at example.com. Now, once I've inserted it, my Postgres is showing a successful message. Let's go to Kafka consumer and see what happens, right? So if you see the Kafka consumer, I'm just printing whatever is happening inside Kafka consumer, right? There's a new ID coming in. The character's name is Charlie Pew, and there is an email, and there is the whole metadata info that Debezium sends to you, right? And if you go to your Spark shell, you see like there is some kind of a progress here, right, indicating that something went on like in a recent, very recently. And if you go to your Spark container and if you list your folder again, now you see 5 files as opposed to the 4 files that we had before. Now this shows us on a very small scale how this architecture can capture these changes in a near real-time fashion, right? We are talking seconds here. Granted, this is a small table and a small insert operation, but you get the picture, right? We didn't do any sort of scheduling. We didn't do anything. We just, pretty much defined how our source tables are going to look like, connect Debezium to it, connect Kafka to Debezium, connect Spark to Kafka, and connect Hudi or connect the end state as some kind of a file system and use Hudi format from Spark, right? That's pretty much what's going on. I think this wraps up our demo. I'll stop sharing my screen. From there, if you have any questions from either Dipankar or from the community, we can go over it.
Awesome. Thank you so much, Sagar. Yeah, and this is really to the point, and even the demo was really succinct and to the point. So thank you so much for taking the time and helping our users. So I'm assuming like this can be made available like as a Docker, with the container and everything to the community as well.
Oh, for sure. I think our plan is to upload it in YouTube like as a library, right? But
yes.
I'll also make sure that this lives somewhere in Hudi repository as well, so that it can be easily spun up and spun down.
Yeah, I think that would be a great reference point for our users who wants to like take it to production and like think of it from architectural point of view, like a
Yeah,
blueprint or something.
yeah,
Cool. I think the one question that I see is from an India is kind of pretty standard. Usually, transaction logs are in proprietary format for each databases. So, does it use database specific connector to read the transaction log from the databases?
yeah. So this is where your Debezium would come into picture, right?
Right.
In our presentation, when we saw, we specifically used Debezium connector that is designed for Postgres. Now, Debezium has a lot of, out of the box connectors like MySQL, SQL Server, all of that is there in Debezium.
Right.
So, it makes it a little easier. All you have to do is change that simple class, and Debezium will be able to process those messages and send it to Kafka. So it's a simple change there. But if you want to do some kind of a proprietary database which doesn't exist in Debezium, that's where you'll have some kind of a manual overhead.
Right. Cool. Thanks, India, for asking that. I think the one thing that I wanted to know is like within the Hudi ecosystem as well, right? Hudi is we think of it as a table format and in general talk about table format, but of course it comes with a bunch of other like
Yeah,
Lakehouse platform specific things and
yeah,
tools. So
yeah,
Hudi Streamer being the one that is like completely used for like ingestion purposes and
yeah.
serves really our purposes. So I'm assuming like Hudi Streamer also provides a more robust integration with DBZM as a connector and allows us to record these changes.
Oh, it does. Yeah. So I think Hudi streamers started supporting Debezium 3-4 years ago, I
Yeah,
think in 2022.
right.
There's a great blog that one of my colleagues wrote. That's there in Hudi site as well. Makes it easier to spin up a Hudi streamer job, which can process all of these Debezium messages without using Spark streaming, right? So
Yeah,
that's where you're not necessarily hooked into a specific platform like Spark or something, right? You can do
right.
everything pretty much with Hudi. That's a really powerful architecture as well, and that's
Yeah.
something that's very common in the community as well. I just wanted to take a different example just to
Mm.
show that this is possible for any Spark folks on how
Yeah,
to do it. So just another way of doing it, but a
sounds
really
good.
popular way is using Hudi Streamer.
Perfect. I think there is another question that just popped up from Adityan. It says which payload format, JSON or Avro, is better to have in Kafka for ingesting to Hudi?
Yeah. So Hudi doesn't necessarily stop you in using either formats. JSON is great, Avro is even better. But when it comes to production, you have to take into you have to take serialization, deserialization, all of that into effect. Like you have to consider all of that. Avro, from a variety of benchmarks, proved to be very efficient when it comes to comparing it with JSON, right? JSON is pretty much a text file, whereas Avro has a lot going on for it. So even in Hudi internally, we use Avro to process log records because it's very fast, right?
Yeah,
And then once the log records are all processed and we run compaction, then we do Parquet. And the reason is because Avro is really fast.
right.
So when it comes to production, I would side with Avro. It probably adds a little more complexity because you have to maintain your schema and all of that. But you know, that is where the power comes in, right? You're not parsing the JSON files every message, right? You
Exactly.
can
Yeah.
go back to the schema, you can deserialize it, and you can read the message.
Got it. Sounds good. Yeah, I think we have probably another question. It's more of a generic thing could be as well. But it says, Kevin says, how do you manage multiple writers to concurrently write to the same Hudi table? Do you recommend any option? I can provide some context
Yeah,
and then probably it's more of a generic thing in general with lakehouse formats and concurrency control. So yes, you can obviously Hudi supports writing multiple writers writing to the same table. And there are a couple of concurrency options to deal with. Hudi specifically brings three different types of concurrency control methods. Optimistic concurrency control being the one that's commonly used for kind of snapshot isolation and this kind of thing. But MVCC multi-version concurrency control also brings that kind of serializable isolation. and provides different like table services, different writers to interact with this different table services and make sure they're not like colliding or something. Uh, Also, like with the recent Hudi 1.0 release, NBCC non-blocking concurrency control is something to look forward to, because that way you are not blocking anything, um, unless that point where you're trying to like make that commit and you acquire a lock for a very specific period of time. So just to sum it up, like there are different options, like in terms of concurrency control, and I can share a blog that I also recently published, and I think that'd be great for the community to go through as well. Cool. I think that is all we had today. And like I said, all these episodes are going to be uploaded to our YouTube channel on Hoodie. So make sure you subscribe to that if you want to follow along. This is a specific playlist for our Lakehouse Chronicles. So we already have 5 episodes out. Episode 6 going to be added there like by tomorrow-ish or by the end of the week. And yeah, and thank you so much again for all our viewers for taking the time and joining us today, in person, in line. And Sagar, once again, really appreciate the time that you had put us to for the demo and everything. Yeah.
Oh, yeah, sure.
All right.
Thanks,
Bye,
everyone.
everyone.